The first algorithm is the most conventional algorithm when it comes to page replacement. This algorithm is called FIFO, first in, first out. The logic behind this is fairly simple. Don't use old pages. So remove. That means if we have number of pages and we want a replacement, we will now target one which was first entered the queue, and last would be the one which was last entered the queue. It is first in, first out, the most conventional way of working. The same principle you might have heard in the queue, which is again first in, first out in nature. Let's try to see a practical diagram and the problem. Suppose we have this data and given with. So we have this data and given with 3 slots. Now let us see how would we solve. In this thing, consider we have 3 slots working with nothing as initially. When we start with the first one page fault will occur. Dot indicates page fault, so 1 gets fitted. Then again page fault, so 1 and 2 gets fitted. Again page fault, 1, 2, 3 fitted. Now the next thing is 4. So 1 gone, 2 gone, 3 gone. Next entry is for 4. Now we have 1, 2 and 3. In this case, as per the rule of FIFO, first in, first out, the entry for 1 was made initially, so 1 would be replaced by 4. Again with the next, what we have is 4, 2, 3. Again 1 is needed. In this case, now longest running was 2, so again 1 would come back. So now what we have inside is 4, 1, 3. Next entry is for 2. Again 2 is not there. Next one to go out would be 3, which will get 2 in. Again next one to go in is 5. What we have is 4, 1 and 2. Longest running is 4, that means FIFO was 4, so that would be replaced by 5. Again there is a page fault, yes, so page fault occurs. Going further, next is 1, but we already have it, so 5, 1, 2, no change. Next is 2, so 5, 1, 2, no issues. Next one to get in is 3, and now if we see, so we have currently in hand is 5, 1, 2, how to handle. Now longest running, if you see guys, see back, there is 1 which has been again and again repeated. It's 1, 2, 3, 4, 5, 6 times getting executed, so it would be replaced by 3. So again there is a page fault. Further, the next one is 5, 3, 2, and what we are seeing it for is for 4. So again does not exist, but the longest running now would remain 5, 1, 2, 3, 4 times. If we say about 2, 1, 2, 3, 4, 5, 6, so it will be still capable, and the next one goes in is similarly for the next cycle, and again there would be a page fault. Similarly for the next and the last one, we have 5, we have 3, we have 4. Next one to go in is 5, which is already present, so no. So in FIFO we have page faults. Total page faults would be 1, 2, 3, 4, 5, 6, 7, 8, 9. You will definitely compare this with other techniques, but fairly simple concept is clear. FIFO, whoever came first would be removed first. So we are talking about the same stuff. We have 9 page faults. Let's go to the next.